Okay guys, sheet 1 here of orthographic projection, solids and contact. Okay, so showing the projections of a cone, we got a point on the surface, explain the generator, and right, I should probably have done that in a different color now. Anyway, doesn't really matter, I suppose. There's a cone sitting on the ground. And if you've got a point on the cone, well, if you put I'll go with a different color here now, like a green string going from the top of the cone to the base of the cone, and that's going through our point. I'll just zoom in on this now a little bit more. Okay, so we can easily find that string or draw that green string in front view and top view. So now the question there is, one of the things that's asked here though is explain the generator. So basically, if you have a line at an angle, and if you revolve a line around an axis, it generates a cone. So a sloping line spun around generates a cone. So the first question here is shown as a projection. Given a point on the surface, find the point and plan using the generator method. So here's our, I find it easier, think of it as a string. There's a string going from the top to the base. Now, this is where it hits the base. And say B for base, which is here. So once you bring that point down, here's where it hits the base, and we then join it back to the top of the cone because we know that's here. There's our string, and we know that that point is on it. So there is our point P. Now question 2 here then beside it is a different way of doing this, and that way is horizontal sections. Now that's based on if you cut a cone horizontally it's going to give you a circle. So and the radius of that circle, you can get that in elevation. So if I chop through this cone here at this, if I chop through the cone at that height, if I come straight down, this is going to be the radius. So once you get your compass, set it to the cone, to the outside of the cone there, that is going to be that is the circle that contains point P. So now that we know P is on that circle, we can just bring it down, and that is point P. Okay, so be careful now. The radius is from the center axis to the outside. That's our radius. So, you know, if this is the front view, it's from the center to the very outside is the radius. So question 3, showing the projections of a cone given a point on the surface, locate this point in elevation. Alright, now look, there's 2 ways of doing that. You could do it backwards. So I think most, well, just move this over here another bit. And I think most people would be okay with, look, working backwards. There's our string or generator. Bring that up to the ground. Return it back to the apex at the top. And P is on it, so it will be there. But I'm going to look at the other way as well. So the other way, working backwards, is just maybe not as easy to picture, but there is an easy way of picturing it. Okay, so an easier way of picturing it is if here is our cone and here's our point. If you put through a hoop that was just the exact right size, that's meant to be horizontal. So if you put a hoop that fitted just exactly at the right size to be around that cone, and then I just bring up the left hand side or the right hand side of this, that horizontal line here is my hoop, there it is, and our point is on that. So when I project that up, that gets me the exact point as well. So that's two different ways of solving that.